Now let us discuss question number 15. So in question number 15 we can see that it is given that an object of mass 1 kg traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. Alright. So, two objects are there. One is a wooden block. Suppose this is a wooden block. Okay. Then another object is this one. Suppose it is coming this side and it strikes the wooden block. That means initially this object is having how much velocity? Suppose I am writing this velocity by u1. u1 is the velocity of the object, which is equal to how much? It is given 10. This one 10. Okay. Now this is the second object. The second object is a wooden block, and the wooden block certainly initially it was at rest because no velocity is mentioned. So for wooden block I will write u2. So u2 is how much? 0. Okay. u1 u2, that is the initial speed. Like in while deriving that momentum, that formula is there, no, conservation of momentum, there I had written ua ub, but here I am writing u1 u2. Okay, that is before collision. Then what happened after collision? After collision both the objects, and one more thing, the mass of this object, is given 1 kg, and the mass of the wooden block, it is 5 kg. So this object is having a mass of 5 kg. Okay. Then after collision what happened? After collision both the object, that means this object and the wooden block, they move off together. That means they stick with one another and they start moving with the same velocity. So that means v1 means the velocity of this object, and v2, the velocity of this object after collision, will be same, which is v only. Okay, so that is the concept. Using this concept only we are going to solve it. So first of all, what we have to calculate the total momentum just before the impact and after the impact. Okay, so for total momentum we know that total momentum before the impact and after the impact will remain same, because according to the conservation of momentum principle we can say this, that the momentum before and after collision remains same. Okay, so first of all let us find out the momentum before collision. So first momentum means momentum of this object of 1 kg mass, that will be how much? 1 into 10, so that is 10. Total momentum, how much it will be? Okay, it is written here, m1 u1 plus m2 u2, that is the total momentum before collision. Okay, so if it is so, if it is before collision, then here you can see that just a second. Okay, so here you can see m1 means how much? 1. u1 means how much? 10. Then plus, as I told you, that u2 is 0 because initially the block was at rest. Okay, so 0 into m2, what it will give us? It will give us 0 only. So that means the total thing comes as 10 into 1 means it is 10. So this is 10 kg meter per second. This is the total momentum before collision. So total momentum after collision will also be the same. Okay, now what else we have to find out? Calculate the velocity of the combined object, that means v. What I told, that this object, these two objects, they are sticking together and moving with the same velocity. How much? Say it is v. That means v1, that is the velocity of this object, v2, velocity of this object, both are equal, and that is equal to how much? V. So we have to find out this v now. Okay, so for that what we can do is this formula. Just now we have calculated this one. Okay, before collision. So before collision if this one, then after collision also same. So after collision we can write that, suppose the mass of this object, the mass of this object and the mass of this object, suppose I am writing the mass of it is m1 and the mass of this is m2, right? So what is the final momentum? Now one more thing, in while calculating the final momentum we will draw it like this. This is the object, this is the wooden block, both are sticking together. So its momentum will be what? m1 v, right? Because v1 is equal to v2, as I told. So m1v, this is the momentum of this object. Then for the block, the momentum is how much? Plus m2v. So from this two term, if you take v common, it comes like this. V common, then what it will be? m1 plus m2. Okay. Then just substitute the value m1 plus m2. And one more thing, since this is the final momentum and initial momentum just now we calculated 10, so we know that initial momentum and final momentum is same, so this should be equal to how much? 10. And from this v will be equal to what? 10 divided by m1 plus m2. And m1 plus m2, you just add the mass of both the object, it comes as 6 kg. Then you divide, the velocity comes as 1.66. so that means 1.66 is the velocity with which both the objects are moving together after sticking off. Okay. Then question number 16. Okay, question number 16 we will discuss, and number 17 will be your homework. Okay, you can just try it once. If you cannot, then tell me, I'll solve. Then number 16, an object of mass 100 kg, an object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. Calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. Alright. So first of all, we will write what are the things given. Mass is given how much? It is given 100 kg. So 100 kg. Initial velocity 5. Alright. U. Final velocity 8. Time 6. So from this thing we can find out the initial momentum. Okay. So initial momentum we can find out. Initial momentum will be how much? What formula actually we are using, or instead of doing this, doing the sum in this way, you can find out in this way also. First of all, calculate the initial and final momentum. Okay, alright, let us do like this only. Initial momentum means mass into initial velocity, this one. So these two we have to multiply, that means 100 into 5, so it gives us 500. Alright, so that is the initial momentum. So initial momentum is 500. Now final momentum. So to get the final momentum, what should we do? Final momentum means mass into final velocity. Okay, not this one. This one, mass into final velocity, that is 8. So we get 800 kg meter per second. Now what we can do? We have to find out force now. So to get force, the formula that we have, F is equal to what? MA. Okay. In this way also you can do, or else you can do it in this way also. Force is equal to you, I think you got this formula, mv minus mu by t. So what is this mv minus mu? This is the change in momentum, right? This is the final momentum. That already we calculated, 800. Initial momentum how much? 500. So here it should be 800 minus 500 means how much? 300 divided by time. Time is how much? 6 seconds. So 300 divided by 6, it gives us how much? 300 by 6 gives us 50. Okay, so this is the answer, 50. In that way you can do. But how they have how it is done here, first it is the calculated acceleration, and then they use the formula F is equal to ma. But instead of that, directly you can use this formula, F is equal to, just now I gave mv then minus mu by t, because already you have calculated mv, final momentum, as well as initial momentum you have calculated. So you just subtract and divide by t. Okay. Then number 18, I think this is the last one. Yes, it is the last one. Number 18, how much momentum will a dumbbell, you know that in exercise, to do exercise, this instrument, this thing is used, right? So dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeter. Take its downward acceleration to be 10 meter per second square. Okay, what I have to find out is the how much momentum the dumbbell can transfer. So momentum, the formula is what? Mass into velocity. The mass of the dumbbell we know, it is 10 kg. But what is the final velocity of the dumbbell when the dumbbell is falling? It is falling from a certain height. Suppose initially the dumbbell is somewhere here and then it falls down. It falls down. Okay. So after, just before it strikes the ground, suppose this is the ground, how much is the velocity of the dumbbell? That will be v. And once we know v, we can find out the momentum by multiplying it with mass, because momentum is mv. So how to calculate this v? What are the things we know? In the question it is given that the dumbbell is falling from a certain height. So whenever it falls from a certain height, or it is dropped from a certain height, we take the initial velocity as 0. We already discussed about it in motion chapter. Okay. Then acceleration is given 10. Final velocity we are supposed to calculate. Distance is given 80 centimeter. In meter if you convert, it is 0.8 meter. So using this formula you know, it is the third formula of motion. I gave you in this way: v square equals to u square plus 2as. Same thing only, v square minus u square equals to 2as. So from here you substitute the value, v we are supposed to calculate, so we will keep it like v square only. u 0, this one, so 0 square is 0 only. Then 2as, so 2a is 10, s means 0.8, the value comes as 16. So v square 16 means v will be square root of 16, which is 4. Now we got velocity, and the mass we already know, it is 10. So what is the momentum then? 10 into 4, which is 40. Here it is given 40. Okay, so this is the answer, 40 meter per second. Okay, so number 17 is your homework. You try. So we have completed this chapter. That means your half yearly syllabus is over. Now you can revise, and if you find any doubt you can ask. Thank you.